Hello guys, to another episode of podcast. Today with medical calculations in Python. So we have to review some data types we did last time with integers, then float, boolean, and strings in integers and float. So let me start by making a simple program that creates two variables, add them together, and store that process in another variable, and store that process in another variable, and then output it, print it out. This variable, I'm going to name it num1. I want it to be an integer. Input, enter your first number. So what I've put inside the double quotes, this string is what is going to be, that is what going to appear on your terminal when you debug the program. Input, the special variable which enables the user to enter data and the data subsequently be entered into the system. So then the second variable num2, then the second variable num2, input, enter your second number. Okay, you are also free along the way to ask questions. Yeah, now I want to create a variable which is going to determine the type of operation I will use for this program. In this instance, I want to just add the two variables. So I'll call the variable sum. This variable called sum, I want it to be an addition of num1 and num2. And I'll subsequently print out the sum. So this variable sum, num1 plus num2, sum goes num1 plus num2. So this is the inputting phase, this is the process. So basically, a simple program contains an input, process, and output. So here num1 and num2, these variables, this position of input. So input, process, then output. So let me try to debug this one. Yeah. Enter your first number. So this text is this one which appear here. So when I enter 23, this number 23 which the user is entered is treated as num1 because of the special function input. So basically I'm assigning num1 to this new value of 23 or whatever the user decides to enter. Same thing for the second variable num2. Enter your second numbers, put maybe 7, 30, 23 plus 7, I think that's 30. So in an instance it became 23. Num2 in an instance it became 7. And when I added those variables, two of them, num1 23 plus num2 7, I got 30. That 30 was equated to sum, a new variable, and that sum is what I've printed out here. Okay, if you're using print, you can use print in another way. I can say the sum is say plus. Yeah, this plus sign in this instance is not addition, it is now called concatenation. Let me input the concatenation. If you are coming from another programming language, maybe VB, this is the equivalent of this sign. It is the same thing, concatenation, by adding together two pieces of items. So in this case, it's not addition, it's concatenation. But the problem is come because this now is a combination of two variables which have different data types. The sum is in double quotes. This now becomes a string by virtue of these double quotes. So this is a string, and this one here it's an integer. So yeah, I have to convert one of them to the other, and in this case I can convert this first string into an integer. So I easily convert sum into a string. How do you do that? Use the keyword str and you put in brackets. So now this is a string plus a string, and the first number, maybe this time 74 plus 4 should be 78. Yeah, the sum is 78. Okay, you can enter things like your questions, you can attend them. Yeah, moving on forward to another operation. This one was sum. Let me go on maybe to subtraction. So for these basic ones, addition, subtraction, multiplication, and division, they are very simple to follow. Mathematical application, mathematical calculations are very easy in Python. So I'll just be changing this portion of the code So for the virtue of having meaningful variables, I'm going to rename this variable to subtract, just having meaningful variables. Now say subtractions. Yeah, now that's good. Alright, another thing, effects in this same program, you may not find the need of having sensible variables, but in a long program which have many variables, it can be confusing if you enter variables which are not meaningful to you. So I've changed this one. The other things, they remain the same. Subtract was num1 minus num2. You can even have third, fourth inputs. Same thing, same process. But in this tutorial, I'm going to stick to 2. So let me debug this one. And the first number 23. My second number, I just want 3. That should be simple to follow. The sum is 20. Okay, I think I have to change difference. Yeah, I think I get the gist of it. Let me redo the same thing. Yeah, 20 difference 20. Yes. You know, move on first to multiplication. Multiplication in coding, we use asterisk sign. This asterisk sign is the symbol of multiplication in computer applications. So say the product is product. Okay, so 4 times 8. 4 times 8. Yeah, 4 times 8. The product is 32. Simple. Just follow these these steps: input, then your process, then your output. Moving forward to division. It'll become quotient. Nine divided by 3. 9 divided by 3 is 3. Yeah. Another special thing about division you have to take note is that automatically when you divide, when you have, in this case, quotient, which is a result of the operation of a division operation, your variable automatically becomes a float. It is not an integer, it's a float. Yeah, it's a float. Even if both your variables, like here, both my variables are integers, but my result is a float. So how can you verify this? You use the function type, and you put on the variable. You check its data type. print type. So to print the type of the data type of this variable called quotient. So I want to divide maybe 32 and 8. So I get 4. Yeah. The type is class. Data type is float. So data type is float. So moving forward, I've covered the 4 basics of mathematical calculations, which is addition, subtraction, multiplication, and division. So moving forward to, so I'll start with the flow division. What is flow division? Flow division is whereby when you divide the things, like in this case, your result is rounded down. It's rounded down automatically. So what you get is a rounded down answer from the said variable. Let me put an example. Division. I just leave it like this. This is save its purpose. Yeah, let me something like 2 divided by 3. 2 and 3. Yeah, I get a 0. The actual answer is, 2 divided by 3, around 0.6 recurrent, 0.6666, something like that. But instead of rounding up, if I was going to round this number 0.67, we would get something like 1, I think. But in this case, we're getting a 0. Why? Because as I have told you, when you use this variable, when you use this operation, after dividing, after getting your 0.6, the computer or the program then round down the answer. So rounding down is something like from 0.01 to maybe something like 0.99. All those variables are rounded down to 0. So they're going to the floor. Rounding to the floor. Floor rounding. Alright. Then I'll move on to another example. Exponential. So what is exponential? I think most of you have done mathematics. It's something like maybe 2 to the power of 2, which is equal to 4. What does that mean? It means 2 times 2. Or maybe let me use another example. 2 to the power of 3, which is equal to 8, which means 2 times 2 times 2. So how do you represent that in Python? We use double asterisk sign, like this. Let's maybe exponent here. Exponent. So we are now on exponential. Exponential. Okay, let me input an example. 2 to the power of 3. Yeah, we're getting 8. 2 to the power of 3 is actually 8. Getting 8. 2 to the power of 3 is actually 8. Okay, so this is exactly like 2 times 2 times 2. This is what I'm talking about. 2 to the power of 3. So we're going to go on. There's something called a modulus. A modulus. Okay, so what is it? We use the special sign percentage. Okay. Percentage. So what is the modulus? When you divide a number, let's say 10 divided by 3. When we say 10 divided by 3, we get 3 remainder 1. If I'm using modulus as my operand, the remainder 1, the 1 will be my output. I'll get the remainder. Okay, let me test it out. So it's now a modulus. Okay, let me debug it. So I'll say 10 mod the 3. Yeah, I get you one. So we're saying 10 divided by 3. The actual answer is 3 remainder 1. But because we are using this operand modulus, I'll get the remainder 1. So how we invoke this operand in Python, we use this percentage sign to denote this operation. Okay, so these are the basics, but also we may have the more complex things, like how do you still remember those expressions whereby you have other portions of an expression which have higher priority over others? What do I say? Like the body mass, how do you denote it in a program? How do you infer priority to other expressions in the same expression? For example, how do you give division priority over multiplication, or division priority over subtraction in a program? So for that you use brackets, the open brackets like this one. Okay, let me maybe put an example. I may want to add this and also subtract maybe the multiplication, okay, the product of num1 by 2, the product of num1 by 2, but I want to start with this portion. So what do I do if I want to do that? I'll use these brackets like this, right? Which means this one will be given priority over the rest. So what else? We'll run. Let me just say for expression. Two, 3. Answer is 1. Okay. You may follow it in a spare time, but num1 will be 2. Num1 will be 2 and num1 will be 2 and num2 will be 3. Okay. Oh, forgetting another one. What else? Then these are the basics. Then maybe we'll move forward. Then let's look on maybe some expressions which saves time and just something like, I think I've seen it in some way, maybe sum. I want to add sum with maybe I say num1 plus 23. Yeah. Actually, let me say this. Let me start creating some here. Then actually say something like this. So what are we doing here? First of all, we have created a new variable called sum, which is an addition of num1 and num2. But before printing out, I've also added 23 to the sum. Let me see if it can run. 2 and 3. The answer is 28. What is happening? Sum equal to 2 plus 3. 2 plus 3 is what? It's 5. Sum goes to sum plus 23. But now we know sum is 5. So sum goes to 5 plus 23, which is equal to 28. 23 plus 5 is 28. But what I wanted to show you is in this expression we can shortcut it. We can shorten it by just saying sum plus equal 23. This expression is the same as saying sum goes to sum plus 23. Sum plus equal 23 is equal to sum equals to sum plus 23. So let me check if it's done again. 2 and 3, 28. Okay, you can do this in all other variables which I've done so far, maybe subtraction, subtract, so just substitute the positive sign with the operation I want to use in that instance. In this case I want to subtract, so I'll use a subtraction sign. Let me say something like maybe 2 and 3. So what is happening here? 2 minus 3, what is it? -1. So it will be -1 minus 23 or -24. Subtract equals to subtract minus 23, of which the subtract is now -1. So it's -1 minus 23. I think that's simple for you guys. So now move on to, I'll use advanced mathematical calculations apart from these ones. With a module in Python called math, so say import math, and in here I want a square, maybe a square root, and the square root of num1. Okay, what do I do? First of all, I import the math module by using the keyword import and stating the name of the module. Okay, so say math, there's the module name, and then I want a function which is inside the module math. And I think we'll also touch on this one when we do the modules. Yeah, but for the sake of those who are ahead, I'm using math, then dot, I state the function I want. You can see all these kind, degrees, distance, exponential thing, factorial, flow, log 10. This power is like same thing as like the exponent, pi, the constant pi, sine, I think for those doing angles, geometry or one. Okay, for example, sine, I can do maybe num1, and let me remove the second variable. Change this one again, sine. And now I have a variable sine. And what is this operation? Like I've said, math is a module which contains function involved in mathematical calculations. So it's a module called math. And in math, in this module called math, there are many functions. An example of it is this function called sine. That sine which is used in geometry, like concerned with angles and stuff. And this function can accept a parameter. In this case, I've assigned the parameter num1, the parameter which is also a variable, so num1. Let me test it out. And if its number just maybe 60. So what I'm doing is I'm finding the value of sine 60 degrees and enter them. So the answer is negative 0.3044. Let me find maybe if I can have a common number. Sine 90. Let me put 90 too. .89. Change cos. Cos 90. 0.4. Okay. Cos h. Cos h. 90. 6 point. Cos h is whereby you cos the power of -1, something like that. But cos h. So in this case, maybe I wanted to do a square root. Back to my original plan. A square root. Now one may be the square root of 9. The answer is 3. So this is how you use the math module. But all these variables, all these functions we can use. You have to be careful on the type of parameters you pass on. Okay, maybe example of a constant multiply. Checking the value of pi. I'm going to pin so that I can have different things here. Because it can cause confusion if I say pine, then pine also. Okay, let me run it. I'll probably recognize because of the type of action I'm inputting. So this value of pi 3.14 and this long number. Yeah. This is how you deal with constants. Maybe one final example. What can I do? Factorial. Yeah, factorial symbol. I'm looking for something which can entertain 2. Yeah, this example, which needs two parameters. So the power, same thing with an exponent, which I did earlier, which uses double asterisk. Same thing here, but just in style. So what do I pass first? Maybe num1. I want num1 to the power of 3, like what I did earlier. So in this function, you pass two parameters. One, that's the base, and the second variable will be your index. So this is how you pass them. Like I said, power is a function which is inside the math module, and for this function power, you pass on the variable, the first variable and the second variable. The first variable will be treated as the base, and the second variable will be your index. So let's run this one. And if you're not sure about how to use this function, you can come over here and see here return x and y. So you need these two parameters. And you can also read, I think there's something here, x to the power of y. Yeah. So it is explaining, so that's a good function. Let me test it out. I want 2 to the power of 3 like I did earlier. 2 to the power of 3, that's 8. Same thing, but just smarter. Okay, so this is how you use mathematical calculations in Python. But maybe just a little bit of error handling. I'll just say it because we are going to have a tutorial dedicated on error handling. So I'll just say what I want to say. They may be input, a user may input data which is not consistent with the variable types in a program, and your program will crash. Example, dividing by 0. Let me do an example. So these are the shortfalls of leaving your code like this. It will crash if the users. This is what we're going to be focusing on when we do error handling. Two divided by 0. Yeah. Division by 0, 0 division error. So error handling, we're going to do try, exception, etc. Okay, that's all I have for you. What else? Let me see if there's anything in the comment section. Any questions? Okay, looks like there's no question in the comment section. So bye for now.